All right, so what I really wanted you to gain from the launch is that arithmetic sequences have a common difference, and if technically you plotted them, it would be a line. So we have, so again, a sequence is a set of numbers with a defined order, not necessarily having a pattern. In each position, n, so like n is 1 is the first term, n is 2 is the second term, and it corresponds to a value for a sub n. So an arithmetic sequence is a sequence with a common difference, and they follow a linear relationship. So we have a recursive formula and we have an explicit formula. The explicit formula can be thought of in two different ways. You can think of this as a sub n equals the first term, a sub 1, plus the common difference times n minus 1. Or if you have the first term and you know the pattern, you can back it up to a sub 0 plus the common difference times n. I personally like this one, and you're going to see me do that more often. It's just my natural inclination. A recursive formula, and you did do this back in Algebra 1. A sub 1 will be a number or a term. A sub n is a sub n minus 1. That just means the one in front of n, the one before n, plus the common difference. Now, this notation here, let me explain this. This funny E symbol means is an element of. Okay, this symbol means is an element of. Then this capital Z stands for the set, put my the in the wrong spot, the set of integers. And what integers are the numbers, say, -3, -2, -1, 0, 1, 2, 3, and so on. So let's just get into these and see if I can circle back to that. So in example A, it says, consider the arithmetic sequence defined as, we'll call it a sub n. So 8 is called the first term. So like n is 1. Then the 5 is the second term, a sub 2. The 2 is in the third term spot, so that's a sub 3. The -1 is in the fourth spot, it's the fourth term, a sub 4. So it says, what is the common difference? Well, you should be able to notice, and this circles back to the launch. So the common difference is -3. So to write a recursive formula, here's how it works. You start with the first term. The first term is 8. Then a sub n is going to be the previous term, a sub n minus 1, and then it's plus the common difference. Well, that happens to be a minus. And then we would write n is greater than or equal to 2, because I can't put 1 in there because I'd have a sub 0. And that's where n is an element of the set of integers. Then it says write two different explicit formulas for this sequence. So I'm going to write each type down, plug in, so you can see the distinction between them. So a sub n, the first term was 8. The common difference was -3, n minus 1. Okay, that's the one I highlighted in the light green. The other one, what I mean by a sub 0 is if I could continue the pattern backwards, what is the one before the first one? Well, I think that one, if I'm moving left, you're adding 3. So that's going to be 11 minus 3n. If you really think about it, if you did this box, 8 minus 3n plus 3, they really truly are equivalent, okay? All right, so then number 4, so I'm still on the same arithmetic sequence. And remember, an arithmetic sequence is a sequence. So it's a list of numbers. Sometimes it can have variables that have a common difference. So it says find the 57th term. So you can use either. Again, I told you I really like this one, so that's my preference. You choose, it doesn't matter. So if I want to find the 57th term, that means n is 57. If you're watching this because you were absent, go ahead and pause the video and see what you get. And I'm getting negative 160. That's the 57th term, or a sub 57. All right, example B. If a sub n represents an arithmetic sequence with a sub 4 is 5 and a sub 7 is negative 13, find a sub 1. This means find the first term. Okay, well, let's do this. If I start with 5, that's a sub 4. Then I'd have a sub 5, a sub 6, and then here's a sub 7. So what's happening is I add the common difference, I add the common difference, and I add the common difference. So I would start with 5 plus 3 common differences is negative 13. So you can subtract 5, and the common difference is negative 6. Now, from here, you can do a couple different things. You can work backwards 3 times. That works. But you could also do this. This is a sub n equals a sub 1 plus d times n minus 1. So if I pick, say, a sub 4 is 5, I'm going to say a sub 4. I don't know a sub 1. I'm going to change this to minus 6, and then that's 4 minus 1. But I know a sub 4. So that's a sub 1. Now that's minus 6 times 3, so that's minus 18. Adding 18 to both sides, a sub 1 is 23. All right, so that ends the notes for us. Thanks.